Hello.
Morning. How are you today?
Doing all right.
All right. And then if you could share your code bunk window and what language are you using today? Python?
Yeah, I don't think.
All right. And here's your question.
A nearly sorted array. So given an array of n elements where each element is at most k away from its target position, devise an algorithm that sorts in n log k time. For example, let's consider k is 2. An element at index 7 in the sorted array can be at indexes 5, 6, 7, 8, and 9 in the given array. Oh, at most k. Okay. So the input array is this with k is equal to 3. The output array. So so that means one of those values could be 3 positions away from its sorted value. Okay. It seems like every number in the input array is at most k positions away from its sorted value. Okay. Okay. So we need to devise a algorithm that goes in log n times log k time.
N log K, not log N.
Yeah, n log k. Right.
Okay.
Right. Okay. All right. So you want to take advantage of the fact that all these numbers are pretty close to where, or rather, we know where numbers kind of need to go. So the first thing I would start thinking through is, are there any sorting algorithms that I can sort of adjust or tweak a little bit to factor in this k property here, right? So the one that comes to mind is quicksort, because maybe I can take advantage of the partitioning logic. And once these partitions get to a length of k, maybe I can change the algorithm a little bit. Or all right, so let's try to play around with some numbers and try and figure out maybe like a strategy here, right? So we have this toy example here. So this is the input and output. So we notice that 3 is 1 position away. We notice that 5 is also 1 position. 6 is 1, 2, 3 positions away. So let's start with like an even smaller array. So if I were to start with just these numbers and k equals 1, how would I sort that? So I know that 5 and 6 were one position away from where they're supposed to be. So so I know I can move 5 1 position over, and I can move 6 1 position over. I know it would be right. So if I expand upon that, in this original array, I know that if I take any one of these numbers and I move it 3 positions left or right, it's going to get into its right position. So how does that help me? If I take a slide, can I take a sliding window? Maybe. of size 3. If I take a sliding window of size 3, I can sort. I can perform a sorting operation within that window. So k equals 3, and then 3 over 2. So it's 4. So I take the min. Oh yeah, I take the min of that window, move it to the beginning, sort. Okay, so I think that's kind of the way to go about it. So if I take a window of size, let's just say k plus 1. I can sort that window and then I can move over. So if I scan that window, yeah, so all right, so just what I'm thinking now is I don't know if you can see me highlighting or anything.
Yep, I can see it.
Okay. So if I take this window here, I find the min and I move 2 to the first position. I find the next min and so on and so forth. What's the runtime of that? So that's I believe that's selection sort. And that's gonna run I think like k squared. It'd be k squared times n divided by k. So if I take k squared, and I divide that by and I times that by n over k, that's going to be k times n over k times n, nk, n times k. So that's not quite n log k. So if I take that window,
What are the structures that you have available to you?
what's that?
All the what algorithms and structures do you have available to you to sort?
Oh, and yeah, maybe I could put it into a heap. So I have heaps. So insertion sort, selection sort, merge sort, quick sort, heap sort. I think a heap might get me closer to where I'm supposed to be. So if I take this window and I make a heap out of it, and I can do k k insertions, that would be k log k. Times n over k. Oh yeah, that'd be k log k times n over k, right? So k log
Would it?
times n over k.
Why would it?
So all right, so it would be, so if I take this sliding window of size k plus 1, and I perform heap sort on that window, that would be k log k, and then that window is then sorted, and then I can move that window over k positions to the next group of numbers, right? And so I don't have to go over n things because the window size is k. So I'd have to go over n over k. essentially I'm moving that window n or k times each time I'm moving it, right? So the number.
Well, what if your data looks like this?
If the data looks like that. So 1, 2, 3. Right. So then that window doesn't. So that means. So basically, in this example, one of the values is right. So everything's not going to fit neatly into that window.
It might, if you think about it a little bit differently.
Okay. So we've got K here is 1, 2, 3. Yes. So this is where, all right, so 8's supposed to be here. Let me just write that down. So that's the window there. And then 6 is supposed to be there. So if we start at the beginning, the very beginning of the array, we know that the first letter, or the first number has to fit within this window, right?
Yep.
Okay, so we know that. So so if we move the first number to, so we start the first. We start the first window. 2, 3, and then yeah, then we've got numbers outside of that window that need to come inside the window. Okay, so maybe it's like a decrease and conquer thing we can do here, because if we just sort the first element.
Well, I do like your idea of a heap.
Okay.
I'll just say that.
Yeah, so okay, so we make a window of size k plus 1. And then, oh yeah, we turn it into a heap. That gives us the first element. Oh yeah, there we go. Here's the first element. And then if we slide the window over, then that will give us the next element, 3. And then we slide the window over. And yeah, okay. Okay, so it's looking like that might be the way to go. So like a modified version of heap sort. We've got this sliding window. And we want to pull from the heap. And okay, yeah, I think that's the way to go. And so we have to call heapify on that window, and then pull the first element off, and then slide it over 1, and then call heapify again. Heapify is going to run. It's going to do log k. yeah, log k operations, and then we're going to do that n times. So I think that's where we want to go.
Okay. Sounds like a good strategy.
Okay, cool. So that's that's your cursor. All right. So let's just define modified heap sort here. I'll pass an array. So we are going to take a oh man, I'm going to have to implement all this stuff. So if we, so what I want to do is I want to so if I take into and then I take the first element off and then move over. And then okay. Yeah, so what I'm going to do is I'm going to define just that window here. And then, oh, we have k that comes in. That's going to be k plus 1, right? Because we want 1, 2, 3. Yes. K plus 1. Okay, so that's over here. So all j is less than length of array. Array. What we want to do is we want to call it's going to be array from I to j, and now we want to call heap on, and we want to heap phi on the temp array, and then so if I'm doing this heap operation, perform the heap operation, and then how do I, oh, I want to do it all in place, right? Because I want to pop it off. What's going to work? Oh, no, I don't have to do that. So then if I, the first element, so array, equal temp, one, one. Let's see, so if I heapify this temp array, so that's going to bring this down here. All right, so if I heapify this window here, and then I pull 2 off and I place it there, and then I'm going to lose that 6. So that 6 needs to, right? Oh, in the temp, I need to, oh, I need to push, yeah, I need to push values into that temporary heap, and then, okay, yeah, that's right. Okay, So I have that temporary heap. I'm going to heap pop, and then heap push. Way. Push into the array. Oh no, first I need to heap define. Okay, so sorry, let me back up here a little bit. So when I build that heap, I want to pull the top value off, and then I want to take the top value off and then put it in there, and then move it over and then push that value on, and then right, because that's going to be in there. Okay, so I'm just trying to make sure that I don't lose any of my values in my logic here. I'm kind of going out of my way not to implement heapify and heap sort like manually. I'm trying to take advantage of all the Python libraries here. So I build a heap out of this, out of here, and then once I do that, it's going to look like, so my heap is going to look something like this. 2, 3, 6, 8. Okay, and then that's my temporary heap, and then so I want to pop that off, and then that's going to be 2, and then that's going to be gone, and then I want to slide that window over and enter a 5, and that would look like this. And then I can pop 3 off, that would be gone, and then I want to enter the 10. Okay, so that looks like it's going to work fine. I'm not going to get rid of any values. That should be fine. Okay. So, so build a heap here, and I just want to build a heap once. I need to keep building it. So let's put that up there. Okay, and then take that. So do this once as well. That up there. Okay. Okay, so once I've got that, I want to pop that item off the heap, put it into the first item, and then I want to then heap push, array J, push under there, and oops, I need to this first. So I put it in the first element, and then I increment that window over 1, and then I put the last element into the heap, and then start over again, putting the first element. Okay, that should be fine. So real quick, I'm assuming that the length of the array has to be at least k in size, right? That's the smallest the array can be.
Yeah.
Yeah. And if that's the case, then I need to adjust my loop here a little bit because it's gonna cut out at the end. And that's not good. So we're going to keep doing that. And then once it gets to the end here, we want to just dump the rest of the heap into the array. So, okay, so once it's out of there, we want to say, well, what happened? So, I don't know why it's giving me syntax error, but that's fine. So then, well, temp I is less than. Okay. Why it's this shit. Maybe ship 10. I have a syntax error somewhere. I'm not seeing it. That's fine. Let's just keep going.
I just think that second while needs to be indented.
Okay. Right. Okay, there we go. Okay. Well, let's listen to that. Then we want to say I. Okay, so that's gonna move. So basically, the way that's gonna work is J. Let's see. K plus 1, so we're at K. So make sure all these indices line up correctly. 2, 4.
3 comes after 2.
Oh. I have a degree in computer science.
There you go.
I swear. And then 0, 1, 2, 3, 4, 5, 6. Okay, so if we start I at 0 and we start J at K plus 1, K is 3, 4. That's too much. Let's grab this guy and back down because, oh wait, this is the original array. This. Okay. So we don't want to do K plus 1. We want to do K. Okay, so we want to start it there. We're doing the heap stuff like I said. And then J is going to go all the way to the end here. And then 1, 2, 3. And then once J is good, so the first 3, this is going to be, and then we just want to dump the rest of the heap from I to the end. Once J kicks out, so J is going to stay to the number path there.
Okay.
Yeah, that should be fine.
I think it looks pretty good. You got there. What is your space complexity?
Space complexity is K. Because we're going to build a heap out of that window. And then we're going to remove an element from it and put it in the original array, or overwrite the original array. And then we're going to push an element back into it.
Okay.
Yeah.
I think that looks good. All right.
Cool. So I'll be expecting an offer letter pretty soon.
So you got there algorithmically. You didn't need much hinting. Your code looks really good, and it's pretty slim. It's probably the slimmest solution I've seen to date. You caught your own bugs. I didn't even have to do anything. So that's a plus. You talked your way through the whole thing. I think you struggled a bit with the strategy, quite a bit. it took a long time for you to come up with the strategy. So my first recommendation is to practice getting to a solid strategy as soon as possible. So maybe the first 5 minutes, make sure you have a solid strategy.
I don't, how do you get better at that? Because that is so, like, if you don't see it, it just takes a lot of like fumbling around to like kind of get there. I just don't.
Yeah, I think it does take a lot of practice. Part of it is seeing problems that are similar and knowing how they're solved. And that's how most people, they experience a particular type of problem and they go, oh, it's a sliding window. Heap, and the log, saying log K is a big clue as to which approach. You started to go down the path of quicksort because you thought, well, I could partition it, but it's still, you're still going to get an NK log K kind of time complexity, which is not ideal. Whenever you're doing like the divide and conquer approaches, you're not going to get as good time complexity. So the heap was perfect.
Okay.
So the other thing is, if you have access to like a bit like leet code, sometimes I just use leet code to come up with a strategy. I don't even try to solve the problem. I just say, well, how would I solve this? Right. And then just practice those, and you can, and try to time yourself. It's like, can I come up with a strategy within 5 or 10 minutes at maximum? 10 minutes max, but it should be within 5 minutes. 5 minutes is ideal.
Right. So you're saying to like go through as many leet code problems and just come up with a strategy? Don't worry
Just
about
a strategy. Don't worry about coding it. The thing that's tough about leet code is that when you run that, you can spend an hour writing these things in leet code because they run every edge case under the sun, and you can spend an hour just trying to figure out what the heck is it finding.
Yeah.
And sometimes it's something dumb like, oh, it should be less than 400 milliseconds, like,
Yeah.
what?
Yeah. Yeah.
Which is great if you're trying to get to the most optimal solution. But what you want to do in your initial strive forward is, what kind of sorting problems are out there? How do I identify which sorting algorithm to use? And then also, I usually write down all the sorting algorithms that I know, that I practiced. Say, well, I've got my divide and conquer ones, and then I've got my brute force ones like insertion sort, selection sort, and then I've got bucket sort, and then I've got heap sort, and heaps, min heaps, and max heaps, and starting with that, say, well, which one of these actually applies to my problem, and then just starting from there, and then practicing. How do I get to a strategy? And you're very visual, which was great. I mean, I think the way that you went through your code was very descriptive, and you even caught a bug in the process, which is great. I was looking at that K+1 or J+1, sorry, when you initialized your temp array, and I'm like, I wonder if he's going to catch that. And you did, and that's the important part, is that you caught it. And so I would say that was good. That was good. But the big concern is how much time did you take? And you didn't get to us. So typically you'll have more than one question in a live interview, right? But if this were a phone screen, you would probably get an on-site.
Okay.
Right? You'd probably, because the phone screens have a low barrier. They're looking for red flags in a phone screen, and they want to give you an opportunity to do well.
Yeah, that's what I thought. And then I did about 6 phone screens, and I got leet code hards on all of them.
Really?
Yeah.
Okay. All right. Sounds good.
Cool. Well, thank you very much. I appreciate the interview experience.
Okay. All right. Well, have a good rest of your day.